Crumlin Formation.
The Newmarket Formation, the Lincolnshire Formation, and the Edinburgh Formation. All right? Do you want me to repeat those? Okay, the first one is the Newmarket. That's the oldest of the bunch. The second is the Lincolnshire, spelled like Abraham Lincoln, S-H-I-R-E, Lincolnshire. And then the last one is the Edinburgh Formation, E-D-I-N-B-U-R-G. N-B-U-R-G, Edinburgh. All right, so these are all carbonate units. All right, they're all essentially limestones. And the beautiful thing about this outcrop is the strata are dipping more steeply than the road is dipping. All right, so as we walk down the road, we're actually walking up through the stratigraphic sequence. Can you guys picture that? All right, so like here's some stratigraphic layers. Okay, they're dipping like this. As we walk down the road, we go from the older towards the younger.
I still see some cross bedding.
Okay, Mike, one thing at a time, all right? All right, so this is cool because it allows us to walk up through time and see what sort of changes happen to these carbonates as time goes by. Let's see what kind of changes happen to the weather here. Jeez. So this one that you're looking at right here is the oldest of the bunch, the Newmarket Formation. And the Newmarket Formation is characterized as being massively bedded. In other words, it's got big, thick, honkin' beds. The overlying younger formation, called the Lincolnshire Formation, is characterized by having really thin, little ribbon-like beds, all right, that are just like a centimeter thick, half a centimeter thick, something like that, okay? So what I want you guys to do is I want you to walk downhill until you think you can spot the contact between the Newmarket and the overlying Lincolnshire Formation. When you think you see it, ask me. But you're looking for a transition from these big fatty beds to little thin beds. Okay, clearly you got some thin beds there. Good job, Stephen. Marcelo, what do you got? Yeah, Marcelo's got the contact right there. You guys see that? Massive bedding of the Newmarket, and then it abruptly stops, and you pick up with these little thin beds of the Lincolnshire. Do you see that? All right. So this is interpreted as being a slight change in the facies, the different limestone facies where these rocks are being deposited, but basically getting towards deeper water. Okay, these are apparently, I don't know much about carbonate sedimentology, but those who do say that this is typical of deeper water sedimentation than the massive stuff here. Something else that I'm noticing as I walk along here is a fair amount of like fossil hash, all right? Little broken up fossil bits and pieces that make up these rocks. None of these are big, sexy fossils that are the sort of thing you would want to put in a museum, but little broken up bits and pieces of living organisms. You guys see those? Yeah. They weather out differently. In some places you can see stuff that's clearly crinoids, clearly brachiopods. Keep your eyes peeled as you go along, but certain layers are very fossil rich, and most of the layers here are actually quite fossil poor. While I'm talking about fossils, I want to show you some pictures. These are pictures that we pulled out, or of fossils that we pulled out of the Edinburgh Formation, which is further down the hill here. This is by one of my former honor students, Anastasia Bogosian Scissors, possibly the best name ever. Basically what happened here is that in certain parts of the Edinburgh Formation, the trilobites have been turned into silica, all right? Now silica doesn't dissolve in acid, but the calcite that makes up the limestone does dissolve in acid. So we just went and sort of indiscriminately whacked away at the outcrop here and brought back a bunch of hunks of rock and sat them in a vat of acid and dissolved the rock away. And what was left was a bunch of mud and some little trilobite fossils. So this is part of the cephalon of a trilobite. Here's part of a pygidium, another pygidium. Here's part of the eye of a trilobite. And here's some of those little horns on the front of the characteristic one called ampix that we were talking about the other day. That is common to North America and also Scotland, right? Everyone remembers talking about that in lecture the other day? Yeah, Alex is nodding and he's like, yeah. No, actually I wasn't in lecture. Yeah, I wasn't there. Anyhow, so these are small little bits and pieces, okay? And they're not whole trilobites, so they're not beautiful fossils. But the thing here is that they're preserved in exquisite detail because of this silicification. So the original trilobite material, which is made out of a material kind of like a crab shell, like chitin, has been replaced with silica. So you get these little tiny, millimeter scale glass sculptures of these different trilobites. So this is a really famous location, not only in interpreting the history of the Appalachians, but also for paleontology. Like the people who write books about trilobites, they talk about the Edinburgh Formation because it's got such exquisite preservation. Yes,
so
Chris.
we might actually see, like, if we like look carefully, we might actually see some fossils and
Yeah,
whatnot.
yeah, you probably will if you're looking carefully enough. All right, so we're gonna keep walking downhill here, and as we walk downhill, you're gonna see some new features. Why don't you? I'm gonna let you guys run it for a little while here. I want you to be noticing things and asking me about them. All right. So challenge yourself to come up with one independent observation about these rocks, and I will do my best to explain it to you.